Question 7. One bag contains red and green balls. Kaylin randomly chooses a ball from the bag. Without replacing it, he chooses second ball. Complete the tree diagram below and draw a probability distribution table for the number of red balls that could be drawn. Okay, so there's 4 possibilities here. We could have red red, red green, green red, and green green. So we're going to need to put the probabilities on these branches and then figure out the probability of any of these 4 things happening before we can do the table. So there was clearly 9 balls altogether, and the chances of getting red were 4 out of 9 and green 5 out of 9. So once we've drawn a red ball, there must be only 3 of them left out of a total of 8 balls if there was 4 out of 9 to start with. So this will be 3 out of 8, and once I've thought that through, this one will be the complement of 3 out of 8, which is 5 out of 8. Down here, if we've drawn a green ball, and there were apparently 5 of them to start with, now that we've got one, there'll only be 4 of them left out of the 8 balls. So 4 out of 8 goes here, and also here, because of course 4 out of 8 has a complement that's also 4 out of 8. So the chances of getting to any of these 4 outcomes, I need to multiply the 2 probabilities together. All of them have 9 and 8 on their denominator, so they're all out of 72 at this point. Nice and easy just to keep them like that. We can say 4 3s are 12, 4 5s are 20, 5 4s are 20, and 5 4s are 20. Now clearly I can simplify all of these fractions. The nice thing about keeping them all with their large denominators in the beginning is that you can quickly use times tables. I don't know about you, but I find it faster to do 5 4s are 20 in my head and 9 8s are 72 than to reach for my calculator, although obviously you could do that. Now 3 of these are the same, so if I simplify one, I've got all of them. So dividing top and bottom by 4 here, I've got 5/18 for all 3 of these. And this one, dividing by 4, I've got 3/18. Now, the nice thing to do here is just to double check that your probabilities do actually all add up to 1. Sure enough, they do, so I've done it correctly. All right, now think about how many red balls could be drawn. If you're drawing 2 balls out of the bag, then either none of them are red, or one of them might be red, or 2 of them are red. So those are my options for X, 0, 1, and 2. And now I just have to write down the probability of getting each one. So the probability of getting no red balls, that would be getting 2 green ones, 5/18. The probability of getting 1 red ball, well, I'll need to add these 2 together because there's 2 ways it could happen, red green or green red. So 5/18 plus another 5/18 is 10/18 or 5/9. Kind of nice to put these down in the simplest fractions that you can. And here 3/18, I can actually make that even better and say it's 1/6. Now why did I not do that before? Having everything with the 18ths, it made it nice and easy for me to double check that 3, 5, 5 and 5 actually added up to 18/18. But now that I'm writing this down, I think it'd be nicer to write it as 1/6. And that's my probability distribution table. Now some of you took it to the next step and started working out expected value. Don't waste time. All you've been asked for is the probability distribution table, which just says the probabilities for the various outcomes. So we're finished.